Hello, everyone. You are welcome to today's lesson. In today's lesson, we are going to continue from where we left off. We are still looking at what trig. In our previous lesson, you remember we were dealing with some application questions under trig, where the question will come in word form, okay, or basically in word problem form. You extract the diagram, then you proceed from there. Okay, in today's lesson, we are going to look at another special application of what? Of trig. Okay, which will be angles of elevation and depression. So by the end of today's lesson, you should be able to identify angles of elevation and depression. And you should be able to deal with questions that involve, okay, the application or the use of what the concept of angles of elevation and depression in dealing with it. So before I take you through what you have on your screens, please don't forget to subscribe, like, and share, okay, my video. So quickly, let's look at what we have on our screens. Angles of elevation and depression. So first of all, I'm going to talk about the angle of elevation. Then after that, what depression. I will take your mind to a particular concept, that or idea or information that you would need, okay, to easily identify these what angles, be it elevation or depression, how to distinguish between the two. Okay, so I read, the angle of elevation is the angle between a horizontal line from the observer and the line of sight to an object that is above the line. So you can see that here we are talking about above. Okay, the line must be above. But above which line? Your horizontal line. So your horizontal line, if you look at this picture, your horizontal line will be your original or your initial line of sight. So if I have my initial line of sight, which is usually taken as the eye level, because the eye level is the eye that we use to sight, okay, see, okay, objects. So in this case, my horizontal line should start from my original eye level without any movement. If I want to observe, if I want to locate, okay, an object above my horizontal line, I need to turn my eye through a certain angle before I can, okay, I need to turn my eye through a certain angle before I can sight an object that is above, okay, this my original line. And that angle that you turn through, okay, to locate the object will be your angle of what? Elevation. So it means here your original line of sight, your new line of sight. So your original line of sight will always be a horizontal line. Your new line of sight, okay, will be usually a diagonal line. So your angle of elevation, you know, angles are formed between two lines. It must be between a horizontal line and a diagonal line. However, the diagonal line must be above the horizontal line. Am I clear?
Yes, please.
So if you, I will come and throw a little more light on that once we get the concept here as well. So I'm through with the elevation. Now let's come to the depression. Okay, the angle of depression is the angle between a horizontal line from the observer and the line of sight to an object that is below the horizontal line. So we are looking at, okay, your object must be below the horizontal line. So this time around below the horizontal line. Okay, so in this case, I have my original line of sight, then my new line of sight. But because my object is below, if I want to sight, I have to look down. And if I look down, obviously, you know, I'm looking at a certain, I need to move through a certain angle. My original, I move down to sight my object, and that angle that I tend to move down to have my object sighted is the angle that we refer to as what? The angle of what? Depression. So if you come here, you can see that indirectly, this is what you have here. You have a horizontal line, okay, then two diagonal lines, one above, one below. The diagonal line above, okay, the angle between that diagonal line and the original line of sight, which is your horizontal line, is the elevation. The angle between your horizontal line and your diagonal line, which is below, will be what? The angle of depression. So anytime you mention depression angle or elevation angle, there is always one line that is constant, that is common to all of them. And what do you think that line will be? Which line is common to all of them?
The horizontal line.
The horizontal line. So anytime you are fixing your angle that we are referring to either as the elevation or depression, and you are not able to say, or you are fixing, you should know that wherever you are fixing the line must, your angle, I should say, your angle must be between a horizontal line and a diagonal line. So immediately you see that one of the major lines, which will be your horizontal line, is missing, then it means there is a problem. So if your angle is between a vertical line and horizontal line, you cannot call it an angle of elevation or depression. If it is between a diagonal line and a vertical line, please take note, it cannot be an angle of what? Elevation or depression. It's always between a diagonal and horizontal. So if you get it wrong, its location wrong, you get it wrong honorably. So if you place it between a diagonal and a horizontal and it's wrong, at least, it will give me an idea that you have that concept. However, if you go and place your angle between a diagonal and a vertical line, obviously I will know that your foundation is very flawed, it's very weak, because your angle cannot be between a diagonal and what? And a vertical line. Okay, Prof. Caroline.
Mr. Akman, please, can you kindly go over it again? Just
what I just said.
Yes, please.
Basically what I'm trying to say is this. Assuming I have this line, I have this line, I have this line. I'm taking this line to be horizontal, this to be vertical. It doesn't look vertical though. I'm taking it to be horizontal, vertical. If I take this angle theta here, this angle here is between horizontal and diagonal, is that not it?
Yes, please.
So it means it's most likely to be either an angle of elevation or depression. Is that okay?
Yes, please.
However, depression, because you know that your diagonal is below the horizontal. Is that clear?
Yes, please.
Now if I come and put, let me call this theta, so beta. Can I say that beta is likely to be an angle of elevation or depression?
No, please.
No, why?
Because it's a vertical line.
Yes, depression, elevation, one of the lines must be horizontal. But here, the two lines that are forming your angle, none of them is a horizontal line. So obviously, you should know that if I locate my angle here, I'm wrong. So you should have this basis, this foundation. That's my point. Is it clear now?
Yes, please.
Thank you. Great. You are welcome. All right. So now that you get the concept, let's see how best we can make use of the concept in dealing with what? Angles of elevation and depression question. So usually it will come. This time I'm not going to give you a diagram to analyze. I'm going to give your question in the statement form. You will bring the diagram, then ask for the analysis. We are all experts. So we'll get there. So let's look at the first worked example, where we can make use of this concept that we've all learned. Please, is my introduction okay to everyone?
Yes, please.
We are all fine. Great. All right. So now this is what we have. Let's read the question carefully. Try to picture the situation, put it in a diagram form. Make it, visual. Then after that, we'll see how best we can, bring the analysis from the picture that we will put forward. So let's see. The angle of elevation. So we know we are dealing with angle of elevation of x from y is 30 degrees. If the length of xy is equal to 40 meters, how high is x above the level of y? So this is the question that we are dealing with. So you can see that here we have two specific points, x and y, all correct.
Yes, sir.
Okay.
Yes, please.
And your angle is taken from which point? Is it X or Y from the question?
Why?
Y. You can see it's clear. Okay, so the angle of elevation of S from Y. So it means Y is going to be our reference point where the angle is taken. Is that clear?
Yes, please.
Okay, so because we are looking at an angle of elevation, you should know at your point of reference, which is Y, if you want to cite X, you mention angle of elevation. So you know when you are elevating, you are going up. So it means your X must be on top or above what? Your Y. Is that clear?
Yes, please.
Please, my professors, I hope you are all with me. Are we all in sync?
Yes, please.
Okay, very good. So now this is what I have. I'm fixing my first point. Okay, so this is my first point. Okay, which is what? Y, where I'm taking my measurement from. Now I need to cite an object which is what? X. Okay, so an object X. And the object, so originally this is your line of sight. Okay, where you take your, you remember there will be a horizontal line. That will be your original line of sight. But my original line of sight, I need to move a certain angle before I can cite an object X. And because the angle is elevation, it means I need to move up. So it means X must be up. X cannot be down by horizontal line. All correct?
Yes, please.
So I am going to position, okay, my X, okay, somewhere here. So this is my point X. Okay, now I join the line, I join the 2 points, okay, X and Y to form a line. So this is what I have. Okay, so obviously you can see that we have 2 lines forming an angle. All correct?
Yes,
Yes,
sir.
please.
Yes,
Okay, so
please.
the angle between this diagonal line and the horizontal line is what is stated in the question as what your angle of elevation, which is 30 degrees. Afar.
Yes, please.
So I
Yes,
will come and
please.
indicate my 30 degrees here. Okay, so this is my angle. Okay, however, remember the question has given you the distance between, okay, X and Y, that is the length XY. So it means I know that the length of what my line XY is what 40 meters. All correct.
Yes,
Yes,
please.
please.
Okay, so now always, okay, you will have a right angle to contend with. The question is asking you to find how high is X above the level of Y. So now the level of Y is this. This is the level of Y. If you want to know how high, okay, X is from the level of Y, then it means I need to come and draw a vertical line through X, okay, to meet my horizontal line. That is my line, okay, through, okay, Y. So let me, okay, put it here, and that will be 90 degrees. All correct. Okay, so please, okay, so here there was a hand up. Somebody's hand was up, and I said I will be with you.
Sir, please, it was me.
Let's go.
Please, have you seen the line that you've drawn, where Y is? Y.
Mhm.
Yes, please. So what if you stretch X so that it meets, like, you X still goes horizontally, upwards, then you connect it along with
No, I
line
don't
Y.
get you. You stretch X, meaning you extend this X.
Yes,
Mhm.
until you're able to line it with the end of line Y.
The end of which line? Y here.
Yes.
This here, this point.
Yeah.
You stretch it up to this, then it come and joins here.
Yes, please.
No issue. I will clear this line. It's not necessary. Okay, where you
Okay.
have your point, just draw this line. Going forward, you see that always you wouldn't have any extensions of the line, so you get only a right angle triangle. I was just trying to make, okay, you know the situation that we are dealing with. So you could have extended this, you could have extended this, and what have you. But it's not, once you fix your point, always there should be a vertical line from your point, okay, to your horizontal. That is the line that will form your 90 degrees angle.
Okay, thank you, sir.
You are welcome. Okay. Hello, my prof. Is my point well made? Are we all on board?
Yes, please.
Okay, so I can proceed, right?
Yes,
Yes,
please.
please.
Wonderful. All right. So now it means this is what we are going to get. So if you look at this situation, this is the diagram from the picture. So instead of giving you, or from the question, instead of giving you this diagram and for you to find this length, because this is the length that is referring towards how high x is above the level of y. So it means we need to find this. Okay, remember I've told you all your vertices must be labeled. So I have a right angle triangle. Two of the vertices came directly from what the question. So I cannot change the name, use any other name. However, this vertex that I have here, I can label it Z or any other letter of my choice. Is that clear? But it should be a capital letter, not a small letter.
Yes, please.
Are represented by capital letters. All other things being equal. All correct, my professors.
Yes, please.
Okay, so
Yes,
now
please.
that I have indicated all my points, my presentation, okay, is going to be easy. Okay, so now what do I do? I am going to, okay, look at the question is asking me to find the side. And remember, if you have a right angle triangle, and I've told you once you have, always indicate where you have your right angle. Don't forget that. Once you have a right angle triangle, you know one of the angles and what, and one side. Okay, you are good to go to find any missing one side. So this side that we are looking for, with reference to the angle, relative to the angle, what will it be? Will it be opposite or adjacent? We know that is automatically the hypotenuse. Okay, so it's these two that we need to make that determination. So will this side be opposite or adjacent relative to this angle?
Opposite.
Opposite. So once we know, and this becomes the adjacent. So I'm going to form my ratio in such a way that we involve only one unknown. Okay, so I'm looking for the opposite and I know the hypotenuse. Okay, so it means if I form, okay, there will only be one unknown. So which ratio do we rely on? So remember, so Katwa. So, okay, Katwa. Which one will be appropriate? Opposite, involving opposite and hypotenuse. Sine, is
So,
that not it?
yes,
Yes,
So
please.
please.
I'll come and
So,
write, okay, okay. Because here is only one diagram. You don't have to come and write from, no, no. Okay, it's when you have more than one, that the one that you are working on, you start from. Okay, I mean, by writing from, let us know the one that you are working with. But here is only one, so it's not necessary. So I will come and write, but, okay, from, oops. Okay, what I have, the figure that I have there, I can say that tan. Oh, did I say tan? Forgive me. Okay, sine. We all pick sine, and I'm going for tan. Okay, it wasn't intentional. Okay, so sine. Okay, 30 degrees. Okay, will be equal to, and please, okay, in the previous assignment, some of you were not able to identify, you cannot identify your opposite from the, what do you call it, the adjacent. Please take notes. Opposite is opposite to the angle, always is reference to the angle. Hypotenuse is fixed. So once you fix your opposite, the last side will be adjacent automatically. So now what do we go? We are going to look at what? Opposite, which is what we don't know, the length of what? XZ. All correct. All over our adjacent, sorry, our hypotenuse, which is what? 40 degrees. That's a 40 degrees, 40 meters. But remember the ratio, this will have a unit meter, this will also have a unit meters. So they will cancel. So when you are substituting, ignore the unit. Is that clear?
Yes, please.
Okay, so now I can say that, you can see that what I have written here, I can see equal to there. So once it's I have equal to there in this, I can come and write this implies that. Okay, so now this implies I'm looking for XZ. So the length of XZ, okay, will be equal to 40 times this. And if you are cross multiplying, please, this is from, okay, using or showing your cross multiplication lines. It's JHS that you do that. SHS, if you do that, it can mean that has been cancelled as well. So please take notes. This is from doing that. Okay, so that will give me 40, okay, times was sine, okay, 30 degrees. Afa, my professors.
Yes, sir.
Yes,
Okay,
please.
so that will be equal to, so you use your calculators to give me, okay, the value of what? 40 sine.
20.
Okay, so sine 30 is what? Is half. So that will give us what? 40 times half. But use your calculator straight away. So that gives us what? 20. And we know the units, okay, length. So that will be what? Meters. So we go and draw our conclusion. Remember, we cannot conclude with this except because, okay, Z came by way of our own introduction. If Z was in the question, then we could have concluded with the exact length that we have here. All correct, my professors?
Yes, please. Please, can
Yes.
you go?
Hello. Somebody's hand was up. Oh, I'm seeing things. So now I come and draw my conclusion. So remember, never forget to draw your conclusion. Very critical. So therefore, here we couldn't have put therefore here, okay, because we are not going to conclude with it. Unlike the other one that whatever that we started with will be what we conclude with. So therefore, we can go and what put therefore up there so that our conclusion will be embedded. This is different. So take note and know, okay, the difference. So in this case, I can say therefore 20 meters, okay, is equal to what? We are asked to find how high is X above the level of Y. Okay, is equal to, okay, how, okay, high, okay, X is above the level of Y. Afar, or you can
Yes,
say
please.
that you can equally say that X is 20 meters above the level of Y is the same thing. Okay, so just draw your conclusion to, okay, bring out this fact. Let the question guide you in drawing your conclusion. Okay, Prof. Frank.
Sir, please, what if like I concluded with line XC is equal to 20 meters at the um end?
No, I said you cannot conclude with XZ because Z, you introduce Z. Avoid concluding with what you introduce. I think I said that in the presentation.
Yes, please.
So please, okay, I don't know, maybe it was your network. Otherwise, always listen attentively. Okay, so I said, but for the Z, you could have concluded, okay, with the XZ. Okay, all right, because we introduced that, so you should always avoid that. I hope I'm clear enough, my professors.
Yes, please.
Okay, wonderful. Okay, so great. So now let's move on to our next, okay, question. Can I move on to the next question?
Yes,
Yes,
please.
Okay,
yes,
wonderful.
please.
Okay, so our next question again. So let's read, picture the situation mentally, then we try to bring the picture to bear in terms of a diagram. Okay, so the angle of elevation of top X. So this one too, we have the points, okay, defined already for us, of a vertical pole from P. So X from P, okay, on a level ground is 60 degrees. This distance from P to the foot of the pole is 55 centimeters. I guess it should be the distance, okay, from P to the foot of the pole, but it still makes sense. Okay, find the height of the pole without using tables. Find the height of the pole without using table. So indirectly, the question is trying to tell you without using calculators as well. So I've told you the two, they work hand in hand. Okay, so let's picture the situation and I'm going to help you deal with it. Okay, going forward, then you will be on your own pretty soon. All right, okay, so let's go. All right, so let's see, picture the situation, the angle of elevation of top X from a vertical, of a vertical pole from P. So I have a vertical pole whose top, okay, is labeled X. I hope you get the point.
Yes, please.
That is the situation that I have there. So let me come and maybe I draw my vertical pole here. You can draw it here. Okay, so I'll tell you which direction if you take and how to deal with it. So I have my vertical pole here. So vertical. This is my pole. Okay, and the pole, the top of the pole is what? Is X. All correct, my profs.
Yes, please.
Okay, and we are told from a point P on the same level ground. So it means the pole, okay, you know every pole must be rooted, okay, indirectly fixed, okay, on the ground. So this is where I have my ground. Okay, I'm using the broken lines to bring out this picture. I'll play the deal with it well. Okay, however, I am told that the point what P, okay, is on the same level ground that is. So it means my point P is supposed to be on this horizontal line. Is that clear? It cannot be anywhere apart from the horizontal ground because it's on the same level ground. All correct.
Yes,
Yes.
please.
Okay, is there anyone here who would want me to come again? I think today I haven't said this, asked this question.
Yes.
Okay. So is there anyone here who would want me to come again?
Yes, please.
Okay, Vanessa. Okay, all right. Where exactly lies the challenge?
Please, I just want you to repeat the last where you said POV.
Okay, so let's read the question. We are told that the angle of elevation of, okay, top X of a vertical pole from P on the same level ground is 40. So it means P is on the same level ground as the foot of what? Of the pole. You get it? So it
Yes,
means
please.
P must be, okay, anywhere on this line. Okay, so if P is here, assuming P is here, okay, if the point P is here, you should know that because I'm talking of angle of elevation, okay, P must sight, okay, X above. And indeed, you can see that P is sighting X above because where I located my P, the horizontal line here, because I'm going to sight X here, my horizontal line will be here, it will not be here. Take note. So I will draw my horizontal line here, so which is already drawn, and I need to turn through a certain angle diagonally, okay, to meet this. So the line between P and X will be your diagonal line. Okay, and the angle here is what we are referring to as the angle of elevation. That's the angle between this your horizontal and the diagonal. All correct.
Yes, please.
Okay, so on that note, I guess I can indicate my 90 here. Okay, then this now becomes a continuous line. Okay, and I know, again, I'm dealing with a right angle triangle. However, remember, we are told that the distance, okay, from P to the foot of the pole. So this is the foot of the pole. Okay, so the distance here and the foot of the pole, they didn't come with a name. So let me call it maybe A. Okay, so it means the distance between A and P will be the 55, okay, centimeters that we have there. Now, professors, are we fine?
Yes, sir.
Okay, so
Yes,
do we
please.
all get the true picture now?
Mr. Akman,
Yes, please, Prof. Carol.
please, when they said the vertical pole from no, the distance from P to the foot of the pole is
Mhm,
55 centimeters.
mhm.
Please, can it be that the P can be indicated at where the 90 degrees is, like at where the A is?
Well, no,
Or
no. If P is here, okay, and X is here, then your angle of elevation before, if you stand here and you want to sight X, can never be 60. It will be 90 degrees.
okay, I just remembered. So
You get it?
yes,
Mhm. So in that one, it means you have to, you know, the angle that you have to turn will be more.
okay,
All right. So I guess the explanation is now, well, okay, taken care of.
yes,
Great. All right. So now that we have this again, we have a right angle triangle. Okay. So if maybe you first of all had your vertical line drawn this way, let me deal with those. Okay. If you had your vertical line drawn, this is the foot, and this is what the top of your vertical pole. So it is your top that must be X. So it means again, if you want to indicate your point, there is the horizontal, the foot will be on the ground. Okay, so if you want to, then your P will be here, okay, and you will join this P and this line. Okay, so your diagram will be the inverted one or the flipped one. You get it? But it's the same diagram. Okay, I have ignored. So your 60 degrees will be here. Okay, and your AA will be here, your 90, and this will be your 55 centimeters. So it's the same diagram, but what more or less flipped. Safa.
Yes, please.
Okay, so now we proceed. The question is asking us to find the height of the pole. So which, okay, length or side will give us the height of the pole? Is it SP, AP, or AX? AX, remember this is your pole. Okay, so this is your pole. So if you are looking for the height of the pole, then it will be the foot to the top. So you are looking for AX. And AX is opposite to this angle. Am I right?
Yes, please.
So opposite is what I'm looking for. However, I know the adjacent. So which trig ratio is it convenient, sorry, for me to use? Okay, so Patricia.
Yeah, please, 10.
Okay, so I'll come and write but, or you can even ignore the but. Okay, then just write tan theta. Okay, so in this case, your theta is 60, 60 degrees will be equal to opposite, which is the length that you are looking for, AX, over the adjacent, which is what? 55. Afa.
Yes.
Okay, all right. So at this point, we are in a comfortable lead. So let me go and clear the side and we come and continue. Having made my point with whatever that I have there. Okay, it's no more needed. So let me clear that. My professors, are we all on board? Have I left anyone behind? Or have you left yourself behind? Let me know so that we've not gone far. At least we can come back and look for you so that we continue the journey together. Good to go? Okay, so you are looking for the length of AX. So I will come and write, okay, this implies that the length of AX, okay, will be equal to, I cannot come and start equal to here. Remember, the statement that I have given here contains an equal to. So I start my next step with implication or I ignore. Okay, so that will give me, it will be 55 times this. So I'm going to get 55, okay, times what? Times 60 degrees. All correct. My professors, are we all fine?
Yes, please.
Yeah, we are okay.
Okay, all right. Okay, so Prof. Sayo, did I get your name right?
Sir, please, yes, it's CIO.
Sayo, I think you mentioned it, just pardon my age. I remember you once, okay. So anyway, so Sayo, you said you just joined.
Yes, please.
What do you mean by just joined?
So, sir, please, I'm coming from the hospital this morning.
Okay, so maybe if you struggle, don't worry. Okay, I pray that you will be able to connect and appreciate whatever that will be said. Otherwise, the video will be shared, then you use that to do
Okay.
it.
Okay.
All right. So speedy recovery, though. All right. Okay. So, all right. So now, what do? We are going to get, okay, your AX to be equal to here. So I'm writing equal to here instead of writing this again. So because 60 degrees is a special angle, if you use your calculator, nobody will know. Okay, 30, 60, 45. Nobody will know. 90, 180, 270, 360. Nobody will know. These are special angles. That at first, okay, now your calculator can give you your answers in terms of said. Okay, but at first, the calculators that we were using, okay, it will give you the answers in decimal. So we were compelled to learn the said result of what the special angles 30, 60, 45. Okay, but here, your calculator can do. So I'm waiting. What is your calculator giving you?
Root 3.
Okay, so that is tan 60.
Yes, sir.
95.2.
That's tan 60, is that not it? So that's going to give you 55, okay, times what? Root of 3. Am I right?
Yes, sir.
Okay, so 55, let me write root of 3. You understand that the same as what? Times root 3. All correct. Let me clear it and write it well. So if immediately you leave your answer in decimal, we'll know that you use your calculator. So take notes. Is that clear?
Yes, please.
Okay, so at this point, you end here. Don't take it to decimal. If you're able to give me the decimal representation of this without using a calculator, okay, that's not to say that, okay, you cannot, you should. But it gives us a hint that you use your calculator or you use tables. So in this case, you end here, you indicate your unit, which will be centimeters. Then you go and draw your conclusion. So I'll write therefore, okay, 55 root what, 3 cm, okay, is equal to what? Okay, pole height or height of pole. Okay, so I will usually write, okay, pole. So, okay, let me height. Okay, maybe at least you get my point. Afa,
Yes, ma'am.
are we all fine, my professors? Is everyone
No.
cool? Hey,
Yes,
we're from the no. I like the vim that you. That's what. If you don't get it, say it with vim. When I'm also explaining again, I will explain with vim. Hey, no, from where?
Is that one, please? The part where you wrote 55. So it's
Oh,
3.
so it's just calculator work. 55 times 60. Do you have your calculator with you?
Yes, please.
Okay, so press 60 and let's see what you get.
Please is a decimal.
No, then it means your calculator, that calculator will not. Go and check the settings. So immediately you write the decimal there, Asemwaba. Your calculator should give you your answer in. Now the calculators that you have and give your answers inside. Okay, so that will be the third representation. That is the root of 3. Okay, so take it to press shift, then the S to D, and let me see if it will work. There is a key like this on your calculator. As if I know the calculator that you are using. So, okay, so there is this key. Okay, so check if you have it. Press shift then that and see if it will take you to the third representation. Otherwise, you get a better calculator because this calculator can expose you big time as okay, just did.
No, please. It's still giving me a decimal.
Okay, so it means that's why I said otherwise, okay, change your calculator. So that's why sometimes you need to wait for your teachers to tell you the sort of calculators that you are supposed to buy. That will be very useful. Okay, all right. So that will be, if you use that, so the answer that you have is the same as root of 3. If you like, okay, record that answer and press root of 3 and compare the two. They will be the same. The decimal that you have there. Is that clear? Okay, so can I move on now? So not that the concept, you don't get it. Okay, it's just this value that's the problem, but you get the concept. Okay, all right. So Prof. ZM, Joshua.
Sir, please. So if we are to solve any question in math and we are told not to use a calculator and we get the answer and it's in a decimal form. So when we get the answer, we should not write it in a decimal form.
No, I don't get you.
So like the question told us that we shouldn't use calculator to solve it. So I want to ask that if you solve and you get the answer
In decimal.
yes, we shouldn't write we shouldn't bring the decimal.
Okay, so you know, even without this question, okay, I've told you that you know for a fact that you avoid, okay, concluding in decimals. You know, I've said that you avoid concluding with an improper fraction unless otherwise stated. So
Okay,
even
sir.
if you use that one as a guide, at least that would have protected you, okay, of some sort at this point.
Okay. Sir,
Because
please take
if you use the decimal will always give you an approximated value. But what give me the approximated value if the actual value is there? You
Okay.
get it?
Yes, sir.
Unless the decimal equally is what? Exact. Assuming maybe it was 1/2 and you wrote that as 0.5. 0.5 and 1/2, they are exact values, not approximate. Though it's decimal. 0.5 is decimal, but it's exact decimal. Okay, but remember, avoid decimal if possible. Only that if it is exact and you don't avoid, it will give you the marks. But if it's not exact and you approximate, you won't get the final answer score.
Okay, sir.
Because if I want you to approximate, specifically, I will tell you, take it to 2 decimal places, 2 significant figures, or what have you. So that's why I always said, unless otherwise stated, I always add these caveats at the end.
Okay.
All right, great.
Sir, please, this only trick that will be asking a question like we shouldn't use calculator.
Oh, no, it's not only trig. You know, even in, what do you call it? The real number system, you did the standard form. Okay, you did board mass. Even board mass questions, sometimes I will tell you without using calculators. Okay, simplify this. Okay, say, is it standard form question without using tables or calculator? Okay, deal with it. Okay, simplify this, evaluate this. So it's not only in trig.
Okay, sir.
All right. Okay. Okay. So I guess we can now proceed, right?
Yes, sir.
So now to the third question. Okay. So this particular question, this is what I am going to do. Okay. So I'm going to pause here. Okay. And you need to draw this. Okay. Get the picture from this. Then send me, capture your picture and put it on the class page. This time around, don't send it to me privately. So I'm pausing. The instruction is explicit. I'll repeat though. All right. So after reviewing, okay, I should say, forgive me, you are welcome back from the water break. Okay, so I've gone through your various submission and exactly what I was talking about. That if you don't take care, okay, you will get the diagram wrong and therefore everything after will be wrong. Okay, I realized that the major concept, the major information that I gave you in the introduction, most of you, and I can say without any equivocation that most of you, okay, fell victim to that. You didn't make use of that information. Remember, I told you in placement of your angle of elevation or depression, it must be between a horizontal line and a diagonal line. So those of you who placed your angle between a diagonal and a vertical line, I was asking myself, who taught you that? Okay, or what is the plan? Because remember, I gave you that information, that vital information, okay, from the beginning for you to do what is expected of you. So please, okay, take note. That shouldn't happen again. Your angle that you put there was between a vertical line and a diagonal line. So you got it wrong, but got it wrong dishonorably. Remember, I've told you you can get something wrong, but get it wrong honorably. Okay, so at least you now know we are going to have the diagram drawn together. So your picture now from the scratch, you know it's wrong. Are you with me, my professor? Don't be too dejected. But my point is, okay, I am okay a little disappointed because I thought you could avoid that. Because remember, I stressed on that and even had to draw, okay, a diagram. Okay, I don't know whether it was Prof. Caro or who. Okay, I had to draw, then let you know. Check, the angle must be between a diagonal and a horizontal. Okay, point well made, my professors.
Yes, please.
So it means some of you are not listening attentively. So let's go and picture the situation. We are told a hawk on top of a tree. So assuming this is my tree. So I'm drawing my tree here. So this is my tree, which will always be a vertical. Okay, so I know going forward you make this mistake again. You've learned your lesson very bitterly. All right, so this is your tree. So a hawk is standing on top of a tree. So assuming this is where your hawk is, I'm using H, okay, to represent the hawk. Okay, it could be any letter. Okay, so because the measurement, okay, so let me continue. On top of a tree, 20 meters high, views a chick on the ground at an angle of depression. So I'm talking of what? An angle of depression. So it means I have to look down, obviously. Okay, find correct to two significant figures. So there is a required approximation. So I have to equally underline that. So with this one, it means you cannot avoid the use of a calculator because you need to approximate the distance of the chick from the bottom of the tree. So we have, okay, the top of the tree where the hawk is, okay, and the bottom of the tree, maybe let me call it B. Okay, so B. Okay, the bottom of the tree. But we are told that the height of the tree is 20 meters. Do you agree?
Yes.
Okay,
Yes,
and we
please.
said once the hawk is on top of the tree, if the hawk must sight what the chick, okay, which is down, okay, your hawk must turn through a certain angle, okay, below your initial or the hawk's initial, okay, line of what sight. So the hawk initial line of sight will be a horizontal, okay, at the point that your hawk is. Okay, so your hawk must turn a certain angle to locate the chick. Okay, so your chick will equally be on the floor. So assuming the same ground as where you have what? The bottom of the tree. Okay, so your chick will be on the ground. So this is where your chick is. I'm using C to represent chick. Is that clear?
Yes, please.
Okay, so obviously we can now say that, okay, this is the line between your hawk, okay, and your 2 points of reference and the chick where the angle is measured. So this is what you have. So you should know that this is the angle that we are referring to because you were originally on this horizontal line, then you turn through this angle, okay, to sight the chick. Okay, so the angle must be below. So in this case, this is the angle that will be the 39 degrees. Okay, it cannot be this angle. So those of you who put the angle here, okay, you know, okay, that you cannot label this angle as angle of elevation because one of the major lines, horizontal line, missing in that formation of the angle. It's my point well made, my professors.
Yes, please.
Okay, all right. Okay, so now if that's the case, then let's okay indicate. Okay, so I'm going to introduce this will be a solid line. Okay, my 90 degrees will be here. Okay, so at the normal circumstance, please take note. Okay, we can let me land Prof. Gideon. After that, I will give you the opportunity if I forget to draw my attention to that. Okay, so now take note. There is nothing wrong, okay, in doing whatever I'm going to do now. What we have to do, this is the original picture. If out of the original picture you want to use it to, okay, do further analysis and give a refined picture, it is allowed. So, but your original picture should have this, okay, angle seen, the angle of depression directly seen there. Okay, however, I know that this line, okay, I don't need a rocket scientist to tell me that this my line on the ground, which is the horizontal line here, and my original line of sight, that's the line of sight of the hawk. Here, these two lines are parallel. Okay, once this is horizontal, they will be parallel. Once they are parallel, this is a transversal. Okay, so once you have power line and a transversal, certain angle properties will crop up. Okay, and one of them will be okay the what the alternate angle. So this angle here and this angle will be the same. So I can equally say without okay fear that the angle here is 39 degrees as well. So indirectly, it's trying to tell us that the angle that the hawk must turn through to sight the chick, okay, down should be the angle that the chick must turn through to sight the hawk. So the angle of what depression, okay, of the chick from the hawk must be equal to the angle of elevation of the hawk from the chick. Should I come again or my point is well made?
Please come again.
Okay. Okay, so if I am on top of something and I want to size someone down, the angle that I need to turn my eye through to size that person down, okay, must also turn a certain angle up to size me up there. So the two angles must be the same. So if I'm up and I'm sighting down, the angle will be depression. But if I'm down and I'm sighting up, okay, an object up, the angle will be elevation. So it means here, my angle of depression of the chick from the hawk, okay, must be the same as the angle of elevation, okay, of the hawk from the chick. Okay, and again, I stand to reason. I did a basic analysis before. We said this line and this line will be horizontal. This will be a transversal, and you know, okay, that property, the Z property of power lines. Okay, this is parallel to that. This angle and this angle must be equal. That is what alternate angles. You remember JHS? My point made, my professors.
Yes, sir.
Okay,
Yes,
so
please.
someone, if you want to use this angle here, the upper angle there, this one, the direct one, okay, then you are supposed to indicate that, then use this one as your 90 degrees. Okay, so use this figure instead. You should know that this length here will be equal to this length here. So this will also be 20. Okay, and you use that figure. But you know this orientation, we are conversant with it. So we are going to use this orientation instead. If you are using this orientation, you don't need to indicate this line. Okay, take note of it. Okay, so at this point, what do? We are going to do a bit of analysis here. Okay, so I have a right angle triangle and I know my opposite, and I'm looking for, the question is asking me to find the distance of the chick from the bottom of the tree. So this is the chick, this is the bottom of the tree. So the question is asking us to find the length of BC. Are we in agreement?
Yes, please.
Hello, my professors, are we in agreement?
Oh, yeah.
Yes?
Yes.
Okay, so on that note, again, I'll come and write but. Okay, then you know, opposite, what I'm looking for is what? The adjacent. So which trig ratio? Tan. Okay, so tan 39 degrees, okay, will be equal to my opposite, which is 20, over the adjacent, which is the BC, the length of BC. Don't forget to put it in the absolute value sign, the length sign. Okay, so now let me go and clear that, then quickly, okay, deal with that. Now, Professor, is everyone following? Have I left anyone behind?
Yes, sir.
Okay, I've left you behind, or the answer to my first question.
Sir, when you joined the diagram, I was trying difficult to connect, so I could not understand how the diagram was
Connect as in your internet.
Yes, sir.
Okay, then I will plead with you. Okay, because we have some few minutes, let me round up. When you get the video, then you watch that part.
Okay.
Okay, thanks for your understanding, Prof. Joshua. Okay, so now let's go. So we are going to get, okay, we are looking for the length of BC. So you know you cross multiply. This length of BC will come and multiply this. So I'm going to get, okay, the length of BC. Okay, tan 39 degrees. Let me write the tan 39 degrees. Okay, will be equal to, is it 20? Yes, 20. Let me write the 20. Well, this is looking like a degrees. Okay, so this is what we have. So I can say that my length of BC, okay, will be equal to 20 over tan 39 degrees. All correct, my professors?
Yes, please.
Okay, so now, okay, the next one becomes a calculator where, so quickly, those with calculators. So you can see that I didn't do my approximation here, okay, before coming to, so I did my change of subject, okay, throughout, finished my change of subject before now coming to use my calculator. So use your calculator to do this, you approximate only, okay, wow. So let's see, here, 20 over tan 39 degrees. My professors, I'm relying on you, quickly.
24.
24.697.
24 point
697.
697. Okay, remember for DPO, first approximation.
6979.
79. I hope you check the next digit.
Yes.
Okay, so 79, what's the unit? Meters. Okay, then you indicate your approximation for DP. Point well made, my professors.
Yes, ma'am.
Okay, then now you
Please.
come and draw your conclusion. Therefore, okay, so what were we asked to find? Okay, distance of what? Okay, the chick. Let me write. Okay, from the bottom of the tree, or tree bottom. I would have written it that way. Okay, so my handwriting is not will be equal to. Okay, let me come here. So remember, in our final answer, we need to convert our answer to two significant figures. We shouldn't forget that. So this is the first significant figure. The second significant figure, you check the next digit, and that will be hot. So you add 1 to this. 5 or more will be hot. So that will give us 2, 5, okay, point. Then the rest will be 0, 0, 0. So you ignore the 0, 0. It will not be, okay, costly. You can omit. So that will be 25, okay, meters. Then you write in bracket 2SF. Indicate your approximation. Afa.
Yes, sir.
All correct, my professors.
Yes, please. Yes, please.
Okay, so okay, on that note, okay, this will be it for today's class. Please, no one is leaving. I haven't taken the last attendance. Okay, so let me end the class and end it well. If you don't have any further questions, okay, I would want to say thank you very much. Okay, and please once again don't forget to subscribe, like and share. So hit the subscribe button, and you can like and share as well. May the good Lord continue to be with us. Bye bye.